even very remarkable, using buttermilk as it is without any pretreatment, up to 99% of the phospholipids were recovered, were extracted with this technology. This is quite remarkable extraction, especially with a consider that amount. So that makes us wonder how this switchable solvent works. So this this technology rely heavily upon this reaction, upon the amine converted into the respective salt and vice versa in the presence of CO2. We did test it in the different stages indicated by numbers here, 1, 2, and 3. We measure the amount of nitrogen just to make sure whether if we are not quantified phospholipid, amine has a phospholipids. And of course, when we combine the byproduct plus the switchable solvent, the nitrogen content was high. And then after the addition of CO2, there was some remaining amine goes into the lipid phase. However, when after the solid phase extraction, no nitrogen content was detected. So it means there are phospholipids and not amine quantified as phospholipid. Going into more details how this switchable solvent works, this is again the percentage of phospholipids using buttermilk and Beta-serum or Beta-serum, and using the traditional metal forge method and the switchable solvent. As I indicated before, the 99% of the phospholipids were extracted, and where the presence of those phospholipids were confirmed by TLC, as indicated in this figure, and we tested also the protein profile by gel electrophoresis. So in this side, we see this side is the standard of proteins, and number 4 represent the B-serum, and number 7 represent the buttermilk, the samples without any treatment. As we added the switchable solvent, the protein profile are changing. So it seems there is a reduction of the disruption of the protein matrix that helps the release of phospholipids into the medium, so the extraction can be a lot easier in that sense. We also quantified the particle size by light scattering, and also using confocal analysis, we stain those phospholipids to quantify and see them under the microscope. In the case of buttermilk, the particle size of the untreated sample was about between 570 something nanometers, and this is a representation in the microscope using confocal microscopy, how the droplets of lipid looks like. As we added the Folch extraction, the size of the droplets reduces for around 400, 450. And when we use switchable solvent, that value reduces up to close to 200 nanometers. So it tells you that not only the protein is disrupted, but also the droplets phospholipids have been reduced. And on this side, you can see a scanning electron microscopy, and this is the buttermilk intact, so untreated material. We can see the protein matrix, how it looks like. When we add the Folch material, the solvent attack the proteins and release the phospholipids, and when we add the switchable solvent, seems like the protein matrix or the proteins are shrink. There's a shrinkage of the protein that helps to release the phospholipid, and also a reduction in the particle size of those phospholipids. Similar studies were observed in Beta-serum, which is a byproduct of anhydrous milk fat, in which the particle size of the intact material or untreated material is around 600 nanometers, and we can see by the size of the droplets under the microscope. As we added the Folch or the organic solvents, the reduction of the particle size goes close to 300 nanometers, and we can see by the image here on the microscope. As we added switchable solvent, the particle size were below 200 nanometers, and we can see by the picture that it's difficult to identify the small particles. And we're also confirmed using scanning electron microscopy here, in which the intact material using Folch and using the switchable solvent, that it seems like the proteins are disrupt. And for two mechanisms are the main, are what we think are the main factors controlling the extraction with switchable solvent. One, it is the disruption of the protein matrix that it seems like it shrinks. It reduces the particle size, and also the droplet size of the lipids is also reduced quite significantly. We also evaluated the individual phospholipid by HPLC, and we had here the distribution of these phospholipids measured by PC, PE, SM, and PS, which corresponds to phosphatidylcholine and the individual phospholipid using Phos method. This is the relative distribution, and this is what we obtained using switchable solvents. So the concentration is quite high compared to the conventional organic solvents. If we plot this, one has percentage of distribution. Now I have to be very careful here by saying this is on this side, this graph is a percentage distribution. So the concentration is different and it's a lot higher in the switchable solvent, but this is a relative distribution of the phospholipids. What is interesting here, from B-serum, or the Beta-serum, we obtain high amount of SM, which is sphingomyelin, which is one of the most bioactive phospholipids. And what it tells you here, the distribution is different when we use switchable solvent, and the concentration is different. So it's quite interesting opportunities that this technology can offer for isolation and even concentration and even isolation of those phospholipids for potential use. Now, I want to share some of the final thoughts about this presentation and where we are heading with this research. Firstly, we demonstrated extraction of milk phospholipid using switchable solvents, and the efficiency of the extraction depends on the type of matrix. It works really well for wet matrix, in the case of buttermilk, for a little bit high when the moisture content is quite high in buttermilk. The other matrix we tested is Beta-serum, B-serum, that total solid is around 20%, and the extraction efficiency was not that high compared to the wet material. So the extraction, the matrix play a big role in the extraction efficiency. We also demonstrate that the portion of the switchable solvent is not converted into a salt. There's a small portion that either remain as amine, it can go to the lipid phase. However, during the solidified extraction or fractionation of the lipids to obtain the phospholipid, that was not present. There are two mechanisms by which the phospholipids, the switchable solvent, extract the phospholipid, and one is the disruption of the protein matrix and reduction of the droplet size of the phospholipids. And we also quantify and identify individual phospholipids. So what is next about this is testing different extraction conditions in order to optimize the process, and tested some pre-treatments in order to obtain even higher quantities of phospholipids, and in the case of Beta-serum, and of course the scaling up of this process. At this moment, this is my contact information. If you have further questions, I will be more than happy to answer by email or during the live session and questions and answers. Thank you very much for your attention.